Hello, everyone. For First Updates Now, I'm Tyler Olds, and you're watching Behind the Bot. It's a fun show where we dive deeper into FTC robots and what makes them work. And today I'm here with team number 9662, Apollo, out of Misgav, Israel. This team has a great history. Just looking at their last couple of years even. Last year at Skystone, they were the finalist alliance of the Israel Championship. Back in Robotics, they won the Inspire Award at the Israel Championship as well, too. So a great team that's joining us. And of course, joining me from Apollo today is going to be Orr, who's going to be talking about the mechanical functions. And Leor is going to be talking about the programming and different sensors on the robot as well. All here coming up on Behind the Bot.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
If you're on an FRC or FTC team and you're currently meeting safely in person and have a functional robot, we'd love to have you on our Behind the Bots or Behind the Bumper segments. Go ahead and reach out to us on any of our social channels, on Discord, or send us an email at admin@firstupdatesnow.com, and let's get your team scheduled to be on First Updates Now. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content. So, Orr, start us out with the mechanics of this robot. We're going to be kind of taking this step by step and going back and forth between you two, but let's start out with the your ring journey with the intake and the shooter. Tell me a little bit more about it.
Okay, so here we have a double-sided intake. We have I don't know what they call these, but like to help the ring pass through, and then these compliant wheels to pass the ring back, up into the magazine. And then on the other side, we have the same thing at first, and then the compliant wheels. But if you can see down there, there are two kind of like doors that help the ring go through and act as a wall for the magazine.
Just a question real quick on that intake there. So what made you choose, I don't know what the fronts are called either, so whatever they're called, but what made you choose from going from that for the first intake and then using compliant wheels on the second? Can you talk to me a little about why you chose like one type of area for the front and a different type of device for the back?
Okay, so at first we were using both as compliant wheels, but we thought that the ring was having trouble being picked up at first. And we tried switching to those and it worked better. We tried other materials that didn't work as well, so we just kept using these.
Yeah, that makes a lot of sense. Can you take us now into kind of the collection area and the shooter itself?
Okay, so here there's the white magazine where all the three rings stuck up, and then the black like kind of floor is the elevator that pushes the rings up.
And then talk to me about the actual shooter itself. So what kind of compression are you using on the wheels? It looks like you got a couple rev motors as well too. So tell me a little bit more about it, and then maybe some of the changes you made throughout the season as well.
Okay, so here we have a little omni wheel, and then a big flywheel. The flywheel has a weight on it to make it more stable between shots. And then the little omni wheel is to push the rings to the flywheel. As the rings go up, they go through the rollers and get pushed into the flywheel. And the two motors here, we have an Andy Mark 1:20 ratio and a Rev 1:1 ratio.
So the way that they travel essentially is one ring will pop up, that omni wheel then pushes it into the shooter, and that flies out. Is that correct?
Yes.
Okay, very cool. Can you talk to me a little bit more about some of the any programming functions that go into it? I know we talked earlier that you might have like a speed control that you use for it. So tell me a little bit more about what you use for that and how some of the programming goes into it.
We use two things to control the speed, the flywheel speed. First, we use a PID controller. It's made to control the flywheel speed, and to know when we can shoot a ring, we use a moving window algorithm. It's like take average of the last speeds of the wheel, and like this we can know the wheel is really in the right speed and not that it just passed there and go to another speed.
Okay, very cool. What was that bar that's on that servo there? Can you describe that a little bit more?
Down here? Oh, the bar up here?
Yeah.
Yes. So this bar is to help us see if the doors down here are open or closed. as we were building them, we thought that there's no way for us to tell if they're opened or closed. So we added a servo up top to let us know.
Oh, okay. That makes a lot of sense, actually. That's pretty cool. I like that. So very neat. Let's continue on and going into your wobble goal mechanism. I know which is mostly mechanical on that, but just talk to me a little about what it is and how you came up with the concept for it.
So at first, we saw that the wobble goal has a little lip at the top. So we thought that if we locked here and started raising it, it will come up with it. And then our wobble goal mechanism is just like a kind of like a, it kind of like helps the drivers make sure they're in the right position to catch the wobble goal. And then we have a servo over here to grab the wobble goal. Then we over here to pull the entire wobble up. We have a 20 kilogram double-sided servo. And then up here, we have another servo to help us lock this in place, because while we're moving, while playing the game, we have the wobble on us to make sure we can put it outside as quick as possible. So we wanted to lock it in place to make sure it doesn't move.
Can you tell me a little bit more about that double-sided servo? I mean, one, I haven't seen too many double-sided servos out there, and then two, that's a lot of weight for that to be lifting. How did you find one that is actually good enough for lifting all that up, but especially with that type of fulcrum?
Oh, okay. So the double-sided servo, it has like one side that is driven like all the other servos, but then it has another side that is kind of like a bearing to help it make sure that the head doesn't break. It just kind of helps it stay alive longer.
No, that's really cool. I just haven't seen that before. So yeah, and so how did you figure out how it's actually gonna, like, how did you do the calculation? Say, okay, I know it's gonna be able to lift this type of fulcrum up with all the weight bearing on it.
Okay, so at first we had really long arms, and the servo was sitting on the plate, but we saw that the servo was having a really, really hard time picking it up. So we raised the servo up and low and made the hands shorter.
So let's finish up here and go to the bottom of your robot, talking a little bit more about the drive. And specifically, I'd like to know more about, it looks like you guys have odometry on your robot, and then anything else you use for like your autonomous or any other sensors you might have.
Okay, so here we have a camera. It's used to see how much ring is on the field in the start of the match. We use the Euphoria image processing. It's come with the first SDK. And also we use the IMU sensor in the rev to know what angle is the robot is. And down here we have two odometries, one for the x-axis, one for the y-axis. They help us to know where is the robot in the autonomous period, and we use we also use in the autonomous period the pure preset algorithm. That we send the coordinates for the robot and the x, y coordinates, and the robot just drives there.
So looking at your program that you've done for your drive and your autonomous, how have you improved that over time? Like where were you at the beginning of the season, and then what have you done to try to make it more accurate and perform better?
And in the start of the season, we didn't have the odometers yet. We know we want to put them, but we didn't
We didn't
manage to do them. So in the start, we drive with the Mecanum encoders. In the drive, we connected the encoder to the drive motors and drive by this. And in the last competition we used the odometers, but not the field odometry. We just drive by the distance the encoder went. And in the next competition we have in Friday. Next Thursday we're going to use the pure pursuit and the field odometry.
Well, 9662, once again, coming out of Misgav, Israel, thank you so much for taking the time to tell us more about your robot and some of the experiences you have as well, too. It's always great to see, what teams are doing and how they're continuing to improve. So wish you best of luck at your next competition, and good luck throughout the rest of the season.
Thank you.
Thank you.
Thanks for watching. If you want more fun content, be sure to subscribe and ring the bell to be notified about our latest videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content.